Hello students, welcome back to e-learning edu. In today's class, we will be learning about the Aufbau principle. So you know that Aufbau principle, this is a very important concept in the field of chemistry, and as a science student, you need to learn about this Aufbau principle. So before going to this Aufbau principle, we need to know various quantum terms and the video upon this quantum mechanics I will be updating that. See here the various terms like n means it is a principal quantum number, and then l is the azimuthal quantum number. So here n indicates the principal quantum number, means in which the electron is present, okay, the shell in which the electron present, and l is the azimuthal quantum number. So here you have the different values for l. For example, l is equal to 0 means it represents the s orbital. Okay, so here for s l is equal to 0, for p l is equal to 1, for d l is equal to 2, and for f l is equal to 3. So you need to know the different terms of this quantum mechanics. And now let us see how to write the electronic configuration for various elements which will be asked for your exam. For example, let me consider the first element, that is the lithium. So lithium, you know the atomic number of lithium is 3, right? So let me write the electronic configuration. So first we have to follow the Aufbau principle. See the Aufbau principle. So here first oneness, right? So it is first is oneness. So I will be writing oneness. So we have to follow this Aufbau principle, that is the arrow mark which I have given. So 1s2 and 3 electrons, right? So 1s2, then the arrow mark towards here. So here 1s2, 2s1, and now count the total number of electron. 2 plus 1 is equal to how much? 3, right? And again let me consider for another element. For example, beryllium, and you know the atomic number of beryllium is 4, right? So 4 means it will be 1s2, 2s2. So in the outermost shell, how many electrons are there in the outermost shell? 2 electrons are there in the outermost shell. So the total number of electron here is 2 plus 2 is equal to 4. 4 electron is present in the beryllium. And next let me consider another example, that is boron. Boron, here the atomic number is 5, right? So here in order to write the electronic configuration, I will follow the Aufbau principle. So see the arrow mark, 1s2, and after 1s2 it is 2s2, and next to see the arrow mark, it is 2p1. 2p1, understood, right? So here 2 plus 2 plus 1, which is equal to 5. So 5 electron is present. And now next boron, carbon, the atomic number is 6, right? So here 1s2, 2s2, 2p2. So here, and when we count in total, the sum of these electrons, it should be 6. So that's how Aufbau principle is. And next carbon. So let me write for the next element, that is the nitrogen. For nitrogen, you know the atomic number is 7, right? So here how you will write 1s2, 2s2, 2p2, sorry 2p3, 2p3. So here for the nitrogen, this is electronic configuration. And for the next element, for example, I will take oxygen. So here oxygen atomic number is 8, right? So here first 1s2, see the Aufbau principle, after 1s2, 2s2, and after 2s2 see the arrow, 2p2, 2p, how much electron should be there in the last shell? So here in order to get it as 8, 2 plus 2 is equal to 4, then how much it should be there? 4. Here 4 electrons. So now count, 4 plus 2 is equal to 6, 7, 8. So here oxygen has 8 electrons. And next oxygen, next is the fluorine atomic number is 9, right? So here 1s2, 2s2, 2p5. Okay, so here 2p5. So count the total number of electron, 5, 6, 7, 8, 9. And next and it follows as it is. And now let me consider another example, sodium. Okay, sodium, the atomic number of sodium is 11, right? So 11. So here when you write the electronic configuration, it will be 1s2, 2s2, then 2p6. Totally now it is 6, 7, 8, 9, 10. So here after 2p6, what is after 2p6? Here 3s1, right? So 3s1. So here 3s1. Now count the number total. Here 11 electron is present in the outermost shell. So this is how we write the electronic configuration for the various elements. And by seeing this electronic configuration, you come to know to which group as well as the which period the element belongs to. So now keep the periodic table with you. See here, in the case of lithium, how many electrons are there in the outermost shell? See, second shell is the outermost shell, right? Second shell is the outermost shell, and in the second shell how many electron is there? One electron is there in the second shell. So here it belongs to which group? First group. So here the number of electron which is present in the outermost shell decides the group. And again, to decide the period, see here in the case of lithium it is 1s2 2s2, right? And to which shell, which is outermost shell? Second shell. So it belongs to the second period. And now go for the beryllium. Beryllium in the outermost shell, how many electron is there? 2 electrons. So it belongs to the second group. And again, period, see here it is having the second shell as the outermost shell, so it belongs to the second period. For boron, how many electrons are there in the outermost shell? 2 plus 1 is equal to 3. So here we will be just adding 10. So 3 plus 10 is equal to 13. So here it belongs to the 13th group. So after 2 we'll be just adding 10. We'll be just adding 10, so that here boron belongs to the 13th group. And which is outermost shell? See here 2s2p. So second shell is the outermost shell, so it belongs to the second period. Now see for carbon. In carbon, how many electrons are there in the outermost shell? 2 plus 2 is equal to 4. 4 electrons are there in the outermost shell. So I have told you, if outermost shell is having more than 2 electron, then we'll be just adding 10. That means it is the 14th group. And again, see, it belongs to which shell? Second shell. Okay. And next for the nitrogen, see here for the nitrogen, how many electrons are there in the outermost shell? 3 plus 2 is equal to 5 electrons are there in the outermost shell. And which is the outermost shell? Second shell. Second shell is the outermost shell. So it belongs to 5 plus 10. How much? 15th group as well as the second period. Okay. For next is for oxygen. See, for oxygen here 4 plus 6, 4 plus 2 is equal to 6. So it has 6 electrons in the outermost shell. So 6 plus 10 is equal to, it belongs to the 16th group. And second shell is the outermost shell, so it belongs to the second period. Similarly, you can go for all the elements which is present in the periodic table. Okay, so that's all for today's class. If you have any doubt, you can just comment me. Okay, so please like, share and subscribe my channel. Thank you.